Okay, it's saying it's recording is pending. Okay, all right. So the recording has started. So welcome again to our CSE 102 online. And what we're going to do today is we're going to talk about interfaces. We're going to finish up the lecture 6 on interfaces and the abstract classes and interfaces, and we'll talk about some of the differences between abstract classes and interfaces. Hopefully you kind of have a good idea of what an abstract class is and how that is how that's useful to us. And then interfaces are going to be, there's going to be some similarities, but there's also going to be some key differences. Okay, so let's get right into it. What I'll do is I will go ahead and share the screen. Let me make sure we're starting from the right spot here. Let me do one thing first. Let's share that. Okay, so I just kind of want to make sure we understand the UML notation for an abstract class. And let me also make sure everyone can hear me. I don't want to be speaking to nobody. Okay, so let's go back. We're going to share that. Okay, so we're going to assume that everyone can hear. Now, what the abstract class is all about is about trying to have some things that some classes have in common, but we know that they're going to be different for all of the children types. Okay, so what that means, all right, thank you, Suleiman. All right, so what that means is that, so remember, in a UML notation, an italicized name of a class or a method means that it's abstract. And what that means is we cannot make an object of that class type. Okay. Also, an abstract method means that it's not defined inside of this class, but it has to be defined inside of all of the children. And the example we looked at with that, we looked at an example of that on last week. And what happened was there was an abstract method in the parent class, and then we made the child, but we did not implement that method in the child class, and the compiler gave us an error. So that would be an example of a compiler error, where the compiler says you cannot make this class unless you implement this other method. Okay, and so the reason why we use this instead of concrete classes up here is because if we were to make this concrete, if number was a concrete class or a non-abstract class, then what would happen is every single method here would have to be implemented here. And then what would happen is that if we didn't implement it down in the child, like in one of the double float long, if we didn't implement these methods down here, that wouldn't be a problem if this was a concrete class. Right? We don't have to override this if the parent is concrete. What this does is it forces our programmer, if they're going to say, I want to make this a type of this, then if I want to make a double a type of number, then that means there are certain things that I'm going to have to do. I'm going to have to make these methods happen. Okay, so that's just kind of a review of what an abstract class is. Remember, the italicized word here means abstract. Non-italicized method means that this method is not abstract. It's actually implemented inside of the number class. That does not prevent me from overriding it in a child class. I can still override this method. That's not a problem. But what that says is that this method has a definition up here in this class. Italicized method says this is an abstract method. This does not have a definition in the abstract class. It must have a definition in any child classes we create. Okay, so hopefully that kind of you understand abstract classes and why they're important and why they're useful. Okay, but an interface is a little bit different. So an interface is a class-like construct. It means that we create it similar to a class. It has some similarities to a class, but just like an abstract class, we cannot create an object of an interface type. Okay, but it's more for describing behaviors and ways that certain types of objects are going to behave. Okay, and certain objects can use these things. Okay, so just like an abstract class, an interface can have abstract methods. The difference is an interface can only have abstract methods. You cannot define a concrete method and a defined method inside of an interface. Okay. And then also, as far as attributes are concerned, the only thing that interfaces allow are constants. We cannot have variable values. We cannot have variable attributes. The only attributes that an interface can have are constants. So we can only have constants, and all of our methods in an interface have to be abstract, which means that any class that uses an interface, it will automatically have a bunch of methods it has to implement. Okay. All right. So some examples: comparable, editable, clonable. We'll go through all of these. Okay. These are all covered as part of this set of lecture slides. Okay. Now, the way that we define an interface, so now we're not doing public class. We also notice you don't have the keyword abstract. So for an abstract class, remember the way that we define that was we use the abstract keyword and then the class keyword, abstract class name. For an interface, however, we use the interface keyword instead of the class, and we don't have to say abstract because an interface by definition is an abstraction, is an abstract type of thing. Okay, you give it an interface name. Same naming conventions as a class. Okay, so we have the first capital letter, everything else lowercase, except if we have like a second name, like a second word in our name, that would be capitalized. So remember this, the term we used to describe this type of naming was camel case. All right, so uppercase, lowercases, uppercase, lowercase, right? So we name it similarly to a class. We give it some constant declarations. We give it some abstract method signatures. Now, the signatures can tell us a lot of stuff, can tell us, okay, what type of return value, what its name is, what its parameters are. But remember from our discussion last week about the abstract methods, it ends in a semicolon. It does not have a definition. We don't have a body. We don't put a body of code down here. Okay. Okay. So, yeah, so an interface, basically, this is very similar to what I already said with the interface is like a special class. Okay, cannot create an object from it, but we still can use it from other classes can use an interface. Now remember that the way that a child class it gains all of the attributes and all of the methods of a parent class was with that extends keyword, right? So remember we said like a chicken here in this example here, we have a chicken extends animal. And what we're saying is that a chicken is a type of animal, right? And a tiger is a type of animal. So they extend the animal. Now here you should be able to very quickly just, if I could cover it with my hand, I would, but you know, this is unfortunately not a possibility. But if we just look at just this part over here, the chicken, animal, tiger section, okay, then everything in this you already know. Everything in this we've already talked about in terms of UML, that a chicken is a type of animal, a tiger is a type of animal. All animals have a sound method. You should be able to tell from the fact that animal and sound are both in italics that that's an abstract class with an abstract method. Okay, so what that means, we cannot create an object of animal. We cannot just create a generic animal. That all animals, as far as this diagram is concerned, all animals that we can create are chicken and tiger. Chicken will have to implement the sound method, and tiger will have to implement the sound method. So, and hopefully we know what chickens and tigers, what sound they make. Although I think in Turkish, animals make different sounds than they do in English. So, so this code, when we look at the examples, I believe the sounds are English-based or American-based animals, and I remember finding out a few years ago in my Turkish class that Turkish animals sometimes make different noises than I'm used to. So anyway, moving on. So the way that we show how an interface might be used by a class is, instead of this solid line, it's the same kind of symbol, right? This triangle with a line, but instead of this solid line, it's a dashed line. It's a dotted line. So what that's saying is that this is an interface, and the chicken here will inherit from the interface just like it inherits from the animal, but it's a different type of inheritance, because now instead of saying that a chicken over here is a chicken is a type of animal, here we're saying chicken is an edible thing, like we can eat chicken, right? Okay, so another thing that I should point out is that classes can have only one parent. Okay, there can only be one class that it extends. However, a class can inherit from an interface from lots of different interfaces. It can inherit from any interface on any number of interfaces. Okay, the keyword we use here instead, here we use extends. The keyword we here use is implements. So a chicken implements the edible interface. Now here we have another example of a fruit that implements the edible interface, right? Fruit is an abstract class. It has two children, orange and apple. So what that means is that apple and orange have everything that fruit has. Fruit has everything that edible has. So what does that mean? Apple and orange have the things in edible. Okay. Now that does not mean that apple is a type of edible class, because edible is not a class, right? But it is an edible type of object. We can eat apples and oranges. As much as my oldest son might disagree with me, he does not ever want to eat fruit. But apple and orange both receive this method how to eat from the edible interface. Okay, we'll take a look at that example in just a moment. One thing I wanted to get to is I wanted to get to that keyword. Let's see. Let's see. There we go. So this is the way that we can show that a class is inherits from an interface. Okay. So here in this first example up here, in all of these examples, right, they extend a certain class. So the class integer extends number. So it's a type of number. It implements comparable. It is a comparable type of object. So we want to be able to compare two things together. Remember, the main problem with just using that greater than, less than, double equals to in classes and in objects is we don't compare their value, we compare what they point to. Are they actually the same thing? And that can give us some weird behavior sometimes. And so what we need to do with a class like integer, a class like big integer, is we want to be able to say that how can we tell which one is bigger than the other, which one is smaller than the other, that kind of thing. Okay. Compared to what it's going to do is it's going to take, it's a method of that class, right? So what's going to happen is it's going to take another object, right, of the same type. It's going to take another object as its parameter, and it's going to return a -1 if this integer. It's going to return, sorry, not specifically a -1. It's going to return a negative number if this object that I'm asking about is less than the object that I'm passing. It's going to return a 0 if they're the same, and it's going to return a positive integer if this one is greater than this one. Okay, if the thing I'm using the method on is greater than the thing I'm passing. Okay, strings do the same thing. All right, we can have a string that is comparable. Remember, we had the compare to, equals, the equals method. There's lots of things we want to be able to do with strings. Okay, so the way that we tell that a string inherits from the comparable interface is we implement the interface. Okay, it extends object. That's not necessary to say extends object. Everything extends object, right? But what we're saying is that strings parent, we're trying to show that strings parent is object, but it also implements an interface called comparable. Okay. All right. So let's see. Look, so if we go back here, then what we've got is we're creating this interface, just an example interface called T1. Now notice that all attributes, all data fields are public, static, final. What that means is it's a constant, right? So all of them are constant. We don't have to put that in here. We don't have to put in public, static, final. If we just do this over here on this right-hand side, because it's an interface, the compiler just understands that is a public, static, final integer. Same thing with the void method. The assumption is all methods are public abstract in an interface, so we don't have to have the public abstract keywords there. Okay, so you don't have to type them in. Save you a little bit of time when you're making a class. Sorry, making an interface for use in like an assignment or something like that, or a lab. Okay. All right. So, let's go ahead and switch over. Well, let me show this one example because this example shows up in the examples that we have for today. All right. So, here we have some examples of how we might compare to something else. Okay. Now, the integer class, we want to be able to compare it. All right. This we might want to compare two strings to each other. We might want to compare two dates to each other. Now, how they're implemented is going to be, we're not going to show that because we don't have access to that integer class source code. But just understand that basically, if this is greater than this, then what's going to happen is it would return a positive number. If this is less, then it's going to return a negative number. If these two have equal value, then it's going to return a 0. Okay, so I'm going to switch over to look at that example. Okay. Now, I have just some descriptive strings here to show what the different values are. Okay, and we compile it. Notice that the value that gets returned, so we say, what if I compare 3 and 5? Okay, well, the value that gets returned here is a -1. Now, you might say, well, why can't I just do let's see. I'm going to take the compare to part off, right? We're going to say, why can't I just ask, is 3 greater than 5, right? All right, so if we run that, you would say, okay, yeah, the 3 is greater than 5 is false. Okay, well, that seems to work, right? So what if I did 5 greater than 3? Okay, and that seems to work too. Now, what may be happening, I was not expecting it to do that actually, so that's kind of strange, because what happens here is that this is actually it's an address, right? It's comparing, because these are two objects. It should be comparing the address. Now, it's possible that this address is greater than this address, and the previous one that the to address was less than the other address. Let's see. Try to see if it does this. Let's see what happens if it does this. Okay, good. There we go. So if instead we asked it, okay, does 5 equal 5? Right? So if I were to do this, and I were to say, okay, does 5 equal 5? And it gives me false, but that's not right, right? We would expect that to be true. And the reason why this is false is because this object that gets created is not the same as this object that gets created, right? So what we need to do is we need to use the compare to, right, to see. Let's see. Take this out. Okay, compare to. So if we change them both to 5, okay, then we get a 0, right? So the compare to will tell us, is this greater than this? Is this equal to this? Is this less than this? Okay, by giving me a negative number, a positive number, or a 0. So, for example, if we said, okay, the 100, what's the comparison between 100 and 5? Okay. 1. Now notice this is not just returning this minus this. Okay, what specifically the compare to for the integer method, how they've implemented it is specifically if this is less than this, it returns a -1. If this is greater than this, it returns a 1. If this is equal to this, it returns a 0. Okay, so let's take a look at another example with strings. Okay, because I want to show how this how the whole string comparison works. Let's see, ABE compared with ABC. Now, which one of these would we expect to be greater than the other? Okay, ABE would be greater because it comes later in the dictionary, in the alphabet, right? So it compares the A, it compares the B, those are both the same. And now E compared with C gives me my answer, right? So if I compile this and run it, right? So ABE compared to ABC gives me the number 2, meaning this is greater than this. Okay, what if I did ABB? Okay, now I get a -1. ABB is less than ABC. What about ABC compared to ABC? And that should give me, I would expect a 0 would come back here. Okay. Now, what if I add a letter to one of them? Okay. Now, which one is greater? For anyone out there that's thinking that A, B, C, D would be greater, right, then you would be correct. Right? A, B, C, D is greater than A, B, C. Basically, it'll compare character by character until either it finds a difference, one character is different from another, or one string just gets completely exhausted. One string, we're done with it. And what happens is that if there's characters left on one string but not on the other, then the one that's longer becomes greater. Okay, as long as all the first characters are all the same. And remember, space is a character, right? So if I compare ABC space to ABC, they're not the same. ABC space is greater than just ABC. Okay. Let's see. And one more thing I wanted to show, the date when you pretty much understand that one, you can probably understand the year, month, day. All right. But I do want to show one other thing with the whole string thing, with the string compare, is you have this whole category and cat. Okay, so which one is going to be greater than the other? Well, the answer, if you've already looked down here, you've seen it a few times, right, is that the result we get is that we're saying category is considered less than cat, which you might think, well, that doesn't seem right. Category is longer than cat. So why is this the same? Why is category less than cat? And the answer is because of this capital letter here and this lowercase letter here. All right. So if it encounters a capital letter in one string at the same spot as a lowercase letter and it's testing those characters, the capital letter is going to be smaller than the lowercase letter in terms of ASCII. Remember, the reason why this is important is ASCII, right? That the C, let's see, it's, if I'm not mistaken, it goes 32 up to 57, I believe, is the uppercase letters, and then the lowercase letters are all 64 up to 89, I think. So check me on that, though. Check me on that if you have time. All right, or if you're interested. But just know, the main thing I want you to know is that uppercase letters come smaller in terms of ASCII than lowercase letters. All right, so if you have a lowercase letter that is being tested against an uppercase letter, the lowercase letter will be bigger in terms of a comparison, like a compare to. Okay. All right. Let's also look at how to implement these the interfaces. Okay. So here, remember, we're going to create this whole edible interface, right? So let's see. Where did we put fruit? It's not that. Trying to find where the here we go. Okay, so we have this edible interface, and the only thing we have in it is this abstract method, how to eat. Now remember, we said we could, so we can compile that, right? And it's fine. And we said we could remove this out, right? And it works the exact same way. Okay, we don't have to have public abstract on a method because it knows that it's public. It knows that it's abstract. Okay, so let's take a look at this, right? So we'll have an abstract class called animal that has an abstract method sound. Now here we do need the public abstract part, right? Because if we don't include that, then it's going to try to create a protected non-abstract method and with just a semicolon, and the compiler will give us an error. The compiler will tell me you don't have a method body, so you have to either make this method happen or you have to tell me that it's abstract. Okay, so that's a difference between abstract classes and interfaces. Okay. Now here we have a class chicken that extends animal, so it's a type of animal, and it implements the edible interface. Okay, so now it's going to have to override all abstract methods in both of these. Okay, so does the order matter? The order does not matter, not one bit. Okay, so I could put this up here. All right, I can change them around, whatever, right? Oh, and you know what? This is actually the Turkish chicken talking. So that's what I was told that a Turkish chicken says. Okay. Another day when I'm not being recorded, maybe I'll make some animal noises for you guys. Okay. All right. So this method comes from the animal class. All right, so we're having to override this method from the animal class. This method comes from the edible interface, how to eat, right? You know, I'm not going to do this guy. I like the rooms much better. Okay, so now if I compile this, as you've seen, this works just fine. If, however, we were to leave a method out, right? If we were to leave an interface method out, it would tell me there's a problem. All right. Chicken is not abstract and it does not override the abstract method how to eat. So I need to have the how to eat method. If I were to leave this method out, I would get the same problem, right? Now it tells me, now the interesting thing here is the compiler will tell me where the method was found, but it doesn't necessarily tell me what type of thing the method was found in. Was it found in an abstract class? Was it found in an interface? I don't know just from this. So I'm gonna have to go find where animal is and see what the deal is, okay? All right, so we have both of these implemented. Now notice that now tiger extends animal, and we override the animal abstract method sound, but we don't have to have the how to eat method, right? Because since tiger doesn't implement the edible interface, I don't have to have a how to eat method. Now, can I have a how to eat method? Sure, right? Tiger can create its own how to eat method. I'm going to uncomment this for just a second. I'm sorry, comment that for just a second. Okay. Now, if I compile this, right, I get no problem because this method, it's simply saying create this method, right? It's not overriding a method. It's just creating this new string how to eat method, right? Now, if I were to uncomment this, let's see what happens. Okay. Now, this is where these can't remember the word for this. If we were in class, I'm sure someone of you would remember this and tell me. But basically, this indicator is saying the method that follows is overriding a method from a parent class or from an interface. Okay, and so if we include this for a method that we expect we are overriding, if we are expecting that we are taking a method in a parent class or an interface and we're overriding it, we put this word in there, right? This override keyword, @override. And then the method that follows, if there's no parent class, if there's no interface that this method is found in, then we're going to get this compiler error, and we're going to tell us, hey, this method doesn't override anything. Why are you including this override? All right. Now, why is this important? Why am I going through all this? Because it's a very useful tool that the compiler is giving us. Because if we override, let's say the how to eat method. Okay. So let's say I'm expecting to override this how to eat method from the edible class. All right. And if I compile this, then I'm going to get this error that says, hey, you didn't override this method, and you're overriding some other method that doesn't exist. Right? If I misname a method, if I type in something wrong, like for example, if I'm expecting the method to be called length, if that's what the name of a method is, and I've seen this a lot in programming students over the last dozen or so years, is oftentimes they'll write this instead, right? And this is in multiple countries. This goes on. This is not just a Turkey thing. So the thing is this is not the same as this, right? And so sometimes we type wrong. Sometimes we expect the method to be called one thing and it's actually called something else. And this is a way that the compiler can help us, right? We can use this compiler directive. I think that's the word I was looking for, was compiler directive, to say, I'm expecting this to be a method that exists somewhere else that I'm overriding it. Okay, so compile it and it's going to say, hey, you didn't override this one, and yeah, this method here, this how to eat, it doesn't exist. So you got to figure out what's going on here. Oh, I see. I misnamed it. Okay. So what the solution would be this. All right. Okay. So then the question is, well, couldn't I just do this? Well, you could, except the problem is you still haven't overridden the actual how to eat method. Okay. All right, now it works. Now everything's fine. The reason why I'm going into such detail with this is, what if, let me go back to animal. What if animal wasn't abstract? And what if so now, I need to take that. Okay, so now we have a non-abstract animal class that has this method sound that returns some value, and we're expecting it to be overridden in children classes. Will this work? And the answer is yes. There's no problem with this. Now, what happens if I say, okay, I'm going to override the sound method. I get no error, but this doesn't actually override this method, does it? Right. So if I were to take the compiler directive and uncomment it, now I get this error, right? Oh, I named it wrong. Ah, I see the problem. I named it wrong. If I leave this out and compile it, I get no compiler problems. Okay. But if I try to create a chicken, I try to create a chicken and I say, okay, what sound does a chicken make? Well, that's not right. That's not what I'm expecting to see. That's not right, is it? So instead, if we take this override and we make sure that we put that compiler directive in there and say, I'm expecting this to override some method, and it gives me this error, I can know, oh, that should be this. That should be sound, not sond or whatever. Right. So now, if I go and create my chicken, and I see what sound it makes, that's what I'm expecting to see. That's correct. Okay. All right, so let's go back and return a lot of this back to the way it was before, making animal back to being an abstract method. I think this is right. I think we got everything right. Okay. All right. Moving on. So we talked about the tiger. Then notice that we have a fruit, an abstract fruit class that implements the edible interface, right? We don't have to have any data fields, any attributes. We don't have to have any methods inside of the fruit class if we don't want them. Right? But it's going to get everything from edible. What does it get from edible? Where's my edible? Oh, it's in the other tab. Right. So it gets this abstract method how to eat. All right. Okay. Now notice that we don't have to override the abstract method here. In fact, we shouldn't, right? Because if this is an abstract class, well, I guess we could. We could override the abstract method here. There would be nothing wrong with that. Public. We wouldn't want to keep it abstract. Right? Because we could just say public abstract string how to eat, like if we wanted to. We can override it, that's fine. Or we could do this. This would be fine. Oh, wait, actually, we need to declare this as abstract. We're going to do it that way. So if we do it like that, the only thing is that this line, if it was there, if it wasn't there, it'd be the same thing, right? So if we don't put it there, all we're saying is that there's an abstract method out there in the edible interface, and when we just don't want to define it here, we're going to define it somewhere below, okay? There is one key difference, okay? So let's see how this works. Let's see how this runs. Okay. Let's see. We created a new apple. That's what we did. Okay. Let me add a new orange there too. Okay. All right. So the reason why I wanted to do this is because if we override a method inside of an abstract class, a method that is defined in an interface, we override it inside of an abstract class with a body. If we override inside the body, we don't get a compiler error. Everything's fine. If we run it, okay, now what's going to happen? We're going to create an array of objects, a tiger, a chicken, an apple, and an orange. Okay. Then we're going to loop through our array, and each time through, we're going to say if it is an instance of edible. If it's a type of edible thing, then I want to say, how do I eat it? Notice one thing here, we're not able to use the object directly because the object is just an object. It doesn't know for sure if it has a how to eat method. We have to cast it to an edible type. Okay. Same thing with animal for getting the sound. Okay. So as we step through, we created our list of objects, our tiger, chicken, apple, orange. Right? Is the first one an instance of edible? Is tiger an edible thing? And the answer's no, at least not. I've never had one. I've never eaten a tiger before. Right? Is it an instance of animal? Yes. Okay. So that's the sound the tiger makes. So you don't want to mess with those guys. Right? Now, is a chicken an instance of edible? The answer is yes. Okay. So we're going to say how to eat it. And then it's also an animal, so we're going to say what sound it makes. Now we're into apple. Apple is an edible thing, so we're going to say how to eat it. But it's not an animal. Orange is an edible thing, so how to eat it. Right? Notice that we never saw this. Right? Okay. So what happens if we don't have this method here? No problem, right? No problem, because since it was overridden here, it means I don't have to override it here. But now that when I run it, my orange object is going to get the fruit how to eat method returned. And if I don't override it in the fruit class, then I'm going to get a compiler error, all right? Because now fruit didn't override it into a concrete method. Orange has to. Basically what happened here is we had an abstract method in the edible interface. In the first example where we overrode it here, what happened was we said, okay, override that abstract method, make it concrete, make it a non-abstract method. Now it has a definition. Fruit inherits from, orange inherits from fruit. It inherits including this concrete method. It now has this concrete how to eat method. So it has no abstract methods. Everything's fine. Okay. If, however, we don't override it here, it means that fruit got an abstract method from edible called how to eat. Is it okay for an abstract class to have an abstract method? Absolutely. There's no problem there. Okay. But then when orange extends fruit, now orange inherits this abstract method called how to eat from fruit who got it from edible. So now fruit has to have a concrete how to eat defined. Okay. So however the method gets made into a concrete method, however an abstract method gets made into a concrete method, the compiler doesn't care how that happens. The compiler only cares that all concrete classes have only concrete methods, which means any method that exists in its parent class, if it's an abstract method, must be defined here. Okay, or if there's a method that exists in the parent's class that's not abstract, that's a concrete method, then we can just inherit it as is. Okay. All right, so I think that covers that part that I wanted to do on terms of examples. Let's move on a little bit. We're going to probably only be here for another 15-20 minutes today, and then we'll continue on with some of this tomorrow. Because one of the other things I wanted to get to was the reason for this whole comparable interface. Okay, so we talked a little bit about this whole comparable interface, about passing one object to another object's compare to method, right? The thing is sometimes we want to know how to be able to compare two objects for the purposes of sorting. right? So if we were to, for example, take two objects, let's see, I think I have it on the rectangle over here. Okay, is you have a rectangle, right? We talked about the whole geometric object. Let me pull up the rectangle here, right? So we have a rectangle defined. It has a width, it has a height. Okay, how do we know which how can we compare two rectangles to each other, two shapes to each other, right? We talked about, let me see, I think, where was it? Test geometric object, was this it? Yeah. The two objects have the same area, question mark, right? Where we checked one object, a circle, we checked a second object, a rectangle, and we said, do they have the same area? And of course, the answer in this situation was no. But that's all we kind of knew, right? That when we defined the equal area method, the only thing we could say was, is this get area the same value as this get area? But what if we wanted to take a bunch of geometric objects and we wanted to not just know, do the areas, do they have equal area or do they have some other similarity? What if we wanted to be able to sort them? We wanted to be able to put them in some type of increasing or decreasing order. And so we can make a comparable object, right? A rectangle that is comparable with other rectangles. We can also do this with geometric objects. I don't think that exists in this set of examples. All right, but we can also do that with the geometric object class. All right, we can have an abstract class that implements an interface. In fact, we saw that, right? We saw here an abstract class fruit implements edible. We could have, where's my geometric object? I think it's over here. All right. We could have the abstract class geometric object. We have that implement comparable, right? So the way, but let's just look at it from a simple point of view, just the rectangle on its own. Okay. So you have a rectangle, right? So when we say that the comparable rectangle extends rectangle, what does that mean? That means that comparable rectangle is a class that we're defining and it inherits from its parent is the rectangle class. So everything that the rectangle class has, we now have in the comparable rectangle class. All right, so that means what all do we get? We get, all right, we actually don't get private things. Remember, we only get the public things. So we get a get width, a set width, a get height, a set height. We have a get area, a get a perimeter. We have all of these methods there. And we can just call the constructor for rectangle with the width height that we pass here. All right. Now remember the compare to method, what does it return? It returns 1 if A is greater than B, right? Or if this is greater than O. It returns 0 if they're equal, and it returns -1 if this is less than O. Okay. And so let's take a look at how they implement this. So what we've decided is that if the area of my current rectangle is greater than the area of my rectangle I'm passing, then we're going to say that this is greater than O. Okay. If the area is less than the area of the rectangle I'm passing to the method, then we just return a -1. Okay, and otherwise we return 0. There's all kinds of other ways we could have done this. Another possibility, I'm going to go ahead and comment it out though. Return get area minus O dot get area. Now this would not work on its own. We would have to do one other thing. right? We'd have to cast it to an integer, right? This would work also, right? Because basically I wouldn't have to, right? And I wouldn't have to have this whole set of if statements if I did it this way, right? This, in theory, should work, right? In fact, what I'm going to do is I'm going to show you a test with this, all right, in just a moment. Okay. All right, so let's go ahead and just run this test, and we'll end on this test. Okay, we'll end the lecture today on this test, and we'll talk about the sorting of comparable things tomorrow. Yeah, tomorrow morning. Okay. All right, so let's create a comparable rectangle. Okay. Actually, let's create a rec. I need to compile first. Okay. So I'm going to create a new with a width and a height of 1, 5, and a height of 5. Okay. Now I want to create an R2, the same thing. Okay. Now, does R1 equal R2? And no, because they don't point to the same thing. Right. Now, okay, well, R1 dot compare to R2, and I'm going to get an error here, right? I don't have that method for a regular rectangle. Right. What I need to do is I need to create comparable rectangle R. Let's call it comparable rectangle. I think that should be right. Okay. And now we're going to do comparable rectangle CR2. Now, does CR1 equal CR2? Oh, good. I made a mistake there. Let's do this. Should have been a double equals. Typo on my part. Okay, CR1 equal CR2. False, right? Because they don't point to the same thing. But now I can compare them to each other. And it comes back with 0. Why? Because the area of the two is the same. Okay, so if I do, okay, what if I do the area is instead of 5 and 5 is 6 and 4? Right? What if the dimensions are 6 and 4? Now, does CR1 compare to CR2? Give me a -1, right? Because CR1 would be considered less than CR2. Okay. What about if CR1 instead of 5 and 5, what if it was 20? Well, no. What if it was 20 by 1? Okay. Which one's greater now? Still CR2, right? 20 times 1 is, it's a very long rectangle, right? But its area is less. Okay. So let's try to see what would happen if I just did this instead. Okay. So now I'm just going to take my get area of my first one minus the get area of my second one, and let's see how well that works. Okay. So I'm going to create my CR1 at 5 and 5. I'm going to create my CR2 to be the same to make sure that, okay, good, they're both the same. All right. Now, what happens if I change that CR1 to a 20 by 1 rectangle. Now my compare to is going to give me a different value, right? But it's still a negative value. Remember, the only thing that the compare to method is going to care about for when we start talking tomorrow, when we talk about the sorting of things, the only thing that it cares about is when I take this and I call the compare to method with another object of a similar type, what happens? Do I get a positive number, a negative number, or 0? That's the only thing it cares about. It doesn't have to be a positive 1, and it doesn't have to be a negative 1. It just has to be a positive, negative, or 0. Okay, so when it does that, if positive, it considers this to be greater than this, than O. If it's negative, then it considers this, my object I'm calling with, to be less than, whatever that definition means, the less than, whatever that means. Okay, so for rectangles, the way that we have defined this and the way we might for any geometric objects, for the comparison of any geometric object, would be does the area, all right, is the area greater than, less than, or equal to? Okay, is that, I'm throwing up air quotes here, but is that the right way to define how two geometric objects should be compared to each other? Maybe, maybe not, right? The way that we chose to say how you can compare two rectangles to each other is one's area greater than, less than, or equal to the other one's area? Right? So what you end up with, so let's say instead of CR1, CR2, right, we do it the other way. You should get the opposite value. And one final thing is, so CR1 is a 20 by 1 rectangle. What if CR2 to be a 1 by 20? Okay. If we do the compare to method with this, what will we get? 0, then you're right. All right, because the two areas are the same. Even though these are not the same rectangle, one is a 1 by 20, one is a 20 by 1, right? They are not the same. Maybe even a better way to see this might be is that if we took the CR1 and made it, instead of a 20 by 1, we made it a 4 by 5. Okay. And we called the compare to method also 0 because the areas are the same. So the way that we defined the compare to method for rectangles for this example is, are the areas the same? Okay. It does not mean that they are the exact same rectangles. If we wanted to have some method, if we wanted to redefine the compare to method that to mean something else, where a 0 is only returned if rectangle A and rectangle B have the same dimensions, we could do that. That would be fine. But then we would have to figure out some way to determine, okay, what does it mean for something to be less than something else? Is it just width? If the width is less than the other width, then that's less than. Or just the height? If the height is less than the other height, that's less than. We don't know, right? We don't. Yeah. But for the purposes of this example and what we'll talk tomorrow about when we talk about the sorting of rectangles, and I encourage you to go ahead and look at those in advance of tomorrow, is the way that we defined it was, if the areas are the same, then it's 0. Otherwise, if the area is greater than the past area, the past object's area, then it's a positive number. It's greater than. And if the area is less than the other area, then it's considered a less than object. Okay. So I'm going to go ahead and stop sharing the screen, and I'm going to see if there's any questions before ending this video and ending this lecture. Okay. So if no one has any questions, then we'll go ahead and call it a day. And again, I encourage you, after I say this, I'll go ahead and end the recording. I encourage you to go ahead and look ahead to the examples, the rest of the examples in the in that lecture examples folder for this lecture. And I encourage you also to look ahead in the slides. We will finish off the lecture 6 abstract classes and interfaces. We'll finish that off tomorrow morning. Okay. And just like last week, we will make this class at 10:30 tomorrow as well, until further notice, until I hear that the Turkish class is meeting or something like that. Okay. All right. Thank you guys, and have a good rest of your day. And we will see you tomorrow.